Ayman?
Okay.
Okay.
All right, back to presentation. Shall continue. So what is the POP testing tool we used? We used in Surface POP mainly two types, the test plug and the cap tester. The difference between the test plug is set inside the tubing spool or casing head spool, the same type and same size and manufacturer for the wellhead, and you open any valves in Surface POP below head valve to check any leak for the test plug while pressure test the POP or to monitoring the well. In cap tester, this one is packing element set in the surface casing below the wellhead, and with inflation it will seal in the surface casing. To detect any leak while pressure test, you keep the pipe is open to the surface, and you install full opening safety valve in case of emergency. So you detect any leak by this way. Both is used for pressure test the POP. This cap tester has advantage because you can pressure test the wellhead connection, but in test plug you cannot pressure test the wellhead connection. The test plug you can unscrew from. You can test blind shear ram. With the cap tester you cannot pressure test blind shear ram. For subsea application or subsea POP, normally it will take time to picking up test plug or cap tester and run and sit in the wellhead. So there is inverted pipe ram in the bottom for the POP. It is used to hang the string inside the well bore and pressure test the POP with. So it is called inverted because it will hold the pressure from the top to apply pressure test for any pipe ram or another above. Okay, this is for saving time. There is POP manufacturer test or shell or body test performed once in factory after manufacture and with the recertification for the POP. When we can do recertification or force certification for POP stack? Every how many years? Every how many years we need to recertificate? Or
5 years.
5 years. Every 5 years, this is the maximum to make full redressing or full check for the POP. You need to replace it with another certified one, and you send this one to the workshop in the OEM or the manufacturer for the POP for checking. Yes, Mr. Saleh.
5 years from the first test or from the first time we start using the
From the time for certification.
Okay.
Okay, it's not from the first test. From the certification from the manufacturer. For any POP less than 10K, when we pressure test that one in the workshop first time, it will use or pressure test up to 200 or twice its rated working pressure. For example, if the certificates is 5K for your POP stack, that means we take safety factor 100 because we pressure tested to 10,000 PSI 2 times. For
Yes.
10K and above, it will be 1.5 or 150%. Like for POP 10K, it is tested in workshop to 15,000 PSI, and the certificate sent to the location with 10K. This is for safety factor. Okay. Now we're going to start talking about surface control system for the POP. Here mainly we'll talk about surface POB stack surface control system, which is simple compared with subsurface system or subsea system. The main component for the direct surface well control system is reservoir tank contain storage for hydraulic oil. What is the minimum requirement for the tank volume for reservoir tank according to the API? How many gallons we need to fill this tank or reservoir tank?
So volume that makes you close, open, and close again for each run.
No. The requirement is twice the usable fluid to close all the BOB function.
You are talking about the reservoir capacity, right?
Yeah, reservoir capacity.
Yeah.
It is twice. Twice the volume. If total volume, for example, 150 to close, you will fill this one with 300 gallon. Okay, this is the requirement for safety. And you have pumping system. The pumping system is two independent source, electrical one, the main one, pump, and pneumatic or air supply pump. The same will be at surface also at the subsea application. This two pumps line up together and take reservoir tank, fluid from reservoir tank, to charging this accumulator bottles found in the rig. The charging up to the maximum accumulator pressure, mainly we use 3000 PSI accumulator, or in some case 5000, until 3000 PSI is full charge accumulator system. The accumulator bottles from beginning at the surface it charges only with nitrogen gas. Its pressure how much? The gas inside the bottle before we start for charging.
Before starting or when charge?
Before start. The pre-charge pressure how much for the bottle?
1000 PSI.
1000 pre-charge 1000 PSI. So the nitrogen, for example, if we take example for standard 10 gallon, so it will be 10 gallon filled with nitrogen inside the bladder, okay, bag. It is almost half pressure, 1000 PSI. It is called pre-charge pressure. From this pressure, we start to fill each bottle with hydraulic fluid up to 3000 PSI. How much time you need to fill or to charge the accumulator to full pressure 3000 PSI according to the API?
Sorry?
How much time you need from 1000 charging to 3000 PSI for a charge?
How much time? 5 minutes?
No, not 5 minutes. This is for surface and subsea within 15 minutes. 15. Why within? Because it is depend on numbers for bottle in the rig. That's why it is within 15 minutes. This is from starting pump to charging bottle from 1000 up to 3000, then the pump is stopped. It takes 15 minutes to full charge. Okay?
For total system.
Total system pressure 3000 PSI.
For example, if we have 10 bottles or if we have 18 bottles, both should be in 15 minutes, right?
Within 15 minutes. Within that mean in range up to 15 minutes. Because it bottle is different from 12, for example. But the maximum time is 15 minutes.
Okay.
Okay. Then you have regulator. You have two regulator for surface. One is for manifold, control the pressure to rams and HCR valves. Another manifold regulator for annular, only for regulating the annular pressure. And you have three-way three-position four-way valve to operate the POP stack. And you have remote control panel as a surface, at least two, one on rig floor and one in emergency place or in tool pusher or around between tool pusher and company man office. Yes, Mr. Saleh.
Mr. Hani, in subsea, it's the same setup for the three position four-way valves.
Everything for surface you will find at the surface on the subsea, but the command or the signal sent to down, it will be different. It's indirect system because you cannot run long lines, hydraulic lines from surface to seabed. It will take long time for response. That's why it's called subsea system, is an indirect system to control the BOP. But this system, reservoir and pumping system, accumulator bottle, you will find in subsea system also.
But I think they have some bottles on the below, right?
This is accumulator bottle in the subsea BOP. Yeah, there is another. And the charging pressure for this bottle in subsea, it is 1000 psi plus the hydrostatic head for the water depth.
Okay.
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 Because it will be affected by the water depth.
Okay.
And the same for remote control panel. You have two at least on the location also to control the BOP remotely without need to access to the main unit.
Mr. Hani, I think in subsea it's electrical, not air operated, right?
Yeah, it is electrical system. Yeah.
Okay.
Okay. Here, this is the basic surface system. This is the bypass valve to operate. So it bypass the manifold here or regulator and they give 3000 psi on the manifold pressure. And this is the regulator for annular. This is the electrical pump. This is the pneumatic pump.
Air pump.
And this is the bottles. It is simple compared to the subsea. For charging, yeah, Mr. Saleh.
No, nothing. I forgot to lower my hand.
Okay, no problem. Okay.
Okay.
This pumping system, electrical and pneumatic or air supply, both is working together to charge the system. But we have setting sensor for low and high for each pump. According to the API, the hydraulic electrical one will start to run if you drop 10% from the pressure for the accumulator bottle. Like if you reach to 90%, which is 2700 psi, the electrical pump start to run automatically to charge the system up to the maximum 3000 or 3050 psi, and then stop automatically. This is the setting for low and high setting switch for the pump. For pneumatic one, for sure it will not set at the same setting value, so it will be less for emergency. So if the system drop to 85%, that means you lose 15% from the system, which is the 2,550 psi, the air pump will start automatically to supply the system back to its normal pressure. Up to 3,000 psi, then stop. Okay. What if the switch for the pump, the high setting, is not to stop charging after 3,000 psi? Here I have another emergency valve, which is called the relief valve here. Accumulator relief valve.
Accumulator relief valve, yes.
Accumulator relief valve, it is automatic setting. Usually, according to the API, it is set 10% above the rated working pressure value for the system. That means it's set at 3,300 psi. At 3,300, it will boom and release the overpressure in the system. Why? To protect these bottles from explosion. Okay.
Correct.
All right. So why I put storage hydraulic oil under pressure in the bottle? Why I need? The system is working with two pumps. If the hydraulic pressure I took to make one function to the BOP is coming less, so the charging pump will start the charging system again to 3,000. This is the concept while operation. Why I need to have 3,000 psi under pressure?
If we lose the power,
Yes.
we may use the trapped pressure inside the.
Yeah. First, to make the closing time for the BOP fast. So you take under pressure volume to close. Second, if you have power failure, like you have fire maybe in the rig, so you need to shut down all the power system. In this case, I can depend on the 3,000 psi in accumulator bottle. And also, this is I can do intentionally, which is called accumulator or drawdown test. I can switch by myself or isolate the pumping system to see the performance for accumulator bottle, how I can do or which function I can make with. What is the function if you isolate pumping system and you use the pressure from the bottle? What is the function I can do for the BOP stack according to the API?
What's that? Come again, please.
I isolate now the pneumatic and electrical pump. This is called drawdown test. I need to check with the 3,000 psi what functions for the BOP I can perform according to the API.
Open, close, open and close.
Close, open, and close.
Close again.
Okay,
All the elements of the BOP stack. Correct?
Actually, unfortunately, it's not correct because this is too much gallons. Really, you need too much gallons to store inside bottle to do this function. You know, usually the closing volume is bigger than the opening volume because the shaft area in the opening chamber. So when you calculate your volume, you calculate based on closed cycle based on the closed volume. If you need to close, open and close, I take all volumes from bottle, it will be too much bottle you need in the rig to do this function. But according to the API for the drawdown test, you can be able with isolation for pump, close all BOP stack, annular and maximum 4 ramps, and open the SCR valve. And the remaining in the gauge, it will be minimum operating pressure called 1,200 psi, accumulator pressure.
Tell me one more time, please. But it is maybe it is according for API, but some of the companies install bottles according to this policy. Yeah, close, open, and close.
Yes, this is what they taught us actually before. They taught us close, open, close.
Okay, it can be policy. So you put yourself in safe side, but according to the API 53,
According to API,
yeah, you need to close all rams and annular, open the HCR valve just to secure the well and record the shut-in pressure. Okay, and the remaining
close
is
all BOP side,
POP, rams and annular, open HCR valve,
open
and the
one
remaining
AC,
one HCR, yeah.
open one ACR,
And the remaining
and it should be
One-
1,200.
1,200, which is called minimum operating pressure for the BOP, or 200 psi above the pre-charge pressure. Yes, Mr. Saleh.
Mr. Hani, as per this, we determined the number of our bottles
Yeah,
as per this, right?
it is depend on the policy. If your policy open, close, open and close, you will calculate your bottles volume based on open,
Yes,
close, open and close with safety factor.
yeah.
Okay,
Okay.
okay, okay.
But how you perform accumulator test in your rig now? You need to close, open, and close. What is the remaining pressure recommended here or asking for?
This is not applicable, actually. I never seen this.
Which one? Accumulator test?
Accumulator test, like they just do the function, regular function tests, and that's it.
No, accumulator test is different from function test. Accumulator test you perform it in some company 2 weeks, every 2 weeks, or was the pressure test for the BOP. You install one pipe
Yeah.
on the surface BOP. You start to have paper for the checklist for the accumulator. So you start to close each ram and you record the time for closing. After that, you isolate your charging pump and you start to close and open what's SCR and you check the remaining pressure on the gauge. If it is 1,200 minimum or above, it will be accepted test.
Exactly.
According to the API.
Exactly.
So what is the accepted test when you close, open, and close again? The same pressure, 1,200?
No, actually, never did this. Usually we have daily checklist for the accumulator, and there is a test for the mechanic. They do the mechanical test for the accumulator.
No, please check.
But if you have one pipe, one shear, one annular, and two ACR, maybe 16 bottles will be enough.
It is depend on the volume for closing.
Yes.
How to get number for bottles? You know, from 3,000 psi down to 1,200, you consume according to Boyle law 1 PV equal PV. You consume usable fluid 5 gallons.
Yes, exactly.
So when you calculate total volume for closing, you divide it by 5 in case of your bottle 10 gallon. So give you number for bottles you need on the rig.
Okay,
If you work with 15 or 20 gallon, it will be different in calculation. Okay. For example, in some policy for client, by asking the minimum operating requirement for drawdown test to be 1,500 psi. Above 1,200.
According to API, it is 1,200, right?
Yeah. The API what said in 1,200 in some condition, after you make close and open HCR, the remaining gauge will not reach to 1,200. You may reach to less. So the API said wait 15 minutes first, then it check the gauge reading again. Why? Because the heating and cooling for nitrogen can affect on the gauge reading. That's why wait 15 minutes. After 15 minutes, if the gauge is not reached to 1,200, wait another 15 minutes. So total 30 minutes will wait. After 30 minutes, if the pressure is less than 1,200, it will not be acceptable test. You need to check. Okay?
So, Mr. Hani, if we have the power disconnected, there's no way to kill a well, right? To remote control a choke.
Yeah, for sure. Only way to record the pressure. That's why you need to close and open the HCR.
Okay.
Okay, but in the API or in accumulator test, you cannot close the shear ram for sure. So it is compensated by opening another ram again.
Okay.
Okay.
Instead of shear ram, you can use pipe ram one more time.
Yeah, one more time. Yeah. All right. This is a BOB control unit for surface BOB. This is a bottle. This is the annular regulator by hand, manual one. This is the BOB. This is the 3-position 4-way valve. It is operated in surface, differ from the subsea. This is open and close, and the position is neutral or block position in the middle. And it is recommended according to the API to not put this one in the middle. If it is in operation, you need to put it in open or close. This is the 4-way 3-position valve. Actually, for surface BOB stack, it usually use selector type. It's called selector type valve. What happened? This is why it's called 4-way, because this is 4 connection. One connection to reservoir tank below, one connection to the gauges 3000 psi, another connection to open the ram, and another connection number 4 to close the ram. That's why it is 4-way, 3-position, open, block, or neutral, and close position. When I push to open, that means the pressure 1500 start to filling opening chamber, pushing the ram away from the tubing or pipe. Then the hydraulic oil in the closing chamber will be drained back to reservoir tank. This is for surface BOB application. But in subsea, it will be little different because you cannot receive again this volume back to reservoir tank as the surface. In block position here, if you put in block position, you will block any leak inside the line. So it will be blind, neutral position. That's why it's not recommended to install in block position while in use. You need to open or close position. In subsea, it differs a little bit because in subsea, there is another type called manipulator type. Have 3-position 4-way also, but the block position in subsea, that means it is drain all pressure in open and closed line to 0. It is called vent position. You vented all the line to the sea, again, the seabed, and make it 0. That's the difference between subsea and surface stack for the selector or 4-way 3-position valve.
In surface,
it is blocked.
If you keep it in block position, that means that there is no oil or fluid in opening chamber or closing chamber, right?
No, in surface, there is pressure trapped here in this line and the pressure trapped in the another line. Just you block and you trap the pressure in both lines.
In both sides.
Yeah, if you have leak, you cannot see it because you put in block position. That's why if you have some leak, some tool pusher, they start to put this one in block position because block position will stop any leak in the circuit to back again to reservoir tank. This is in the surface, BOB.
Tell me one more time. In block position.
In block position?
Yes.
The 2 line here has 1500 psi. Okay. If you have leak in one valve or on the line here, So the pressure will drop in manifold and the accumulator will drop because there is leak in the line or in the valve. But if you put the valve in neutral here or block, you block the leak again, so the pressure will not drop because you hold the pressure in post line.
Both line has 1,500 psi, huh?
Yeah, post have 1,500.
But if there is a leak in line,
if there is leak in the line, the manifold will drop, accumulator will drop later, then the charging pump will be continuously working. This gives you indication you have leak in the circuit. You need to check. And sometimes this selector valve may be leaking fluid. So when you put in plug position, you will stop this leak. You will not see.
Correct.
Okay.
Yes.
Here, this is the 3 pressure. 3,000 for accumulator full, 1,500 for manifold, and for annular, it is almost less than 1,000 according to the operation. This is the cover to protect or to give alert for the driller. This is blind or shear ram before you operate, and in some company there is alarm can be sound up if you remove this plate or before start to operate the blind shear, because by mistake in some rigs the driller come and shear the pipe. It is used here. You can find in main control unit or also in another setting alarm for the remote control panel also.
Sometimes some rigs does not have this type of cover on the this valve on the blind, and sometimes some drillers or some derrickman or whoever it is
To cut.
activate this valve accidentally.
Yeah. That's why you need to put cover.
Yeah, but since it is shear on 3,000 psi, there is no problem.
But if you operate the shear at 1,500, it can be
collapse.
cut or collapse your pipe.
Collapse, yeah.
In some condition, it can cut some tubular.
Yes.
Yeah. Like in Saudi Aramco, they put this cover, and in the end for the cover, there is a screw connected to electrical sensor. When you start to move that one, it sound and give you alarm, take care, you are going to share.
Yeah.
This is for safety.
Yeah.
Here, this is the electrical one, pump, pneumatic one. And this is the calculation for accumulator. This is the full charge, 3,000 psi. This is minimum operating pressure, and this is the pre-charge pressure for 10-gallon calculation for bottle. You consumed here from 6.7 gallon hydraulic down to 1.7. So you consumed 5 gallon from each tank between operation from 3,000 up to 1,200 psi.
So 5 gallons is usable.
Usable fluid, yeah. That's why you divided the total volume for closing by 5. It's not by 10, because 10 is contain nitrogen.
Mr. Han, this is for any operation?
This is for surface bottle, is not for subsea.
Yeah, but for any operation?
For any operation, if you have 15, you can apply this pressure boil low B1 V1 equal B2 V2 to get the pressure for the gas or volume for the gas, and the rest it will be for the oil. Okay. This is the remote control panel. It can be electrical one, or it can be working with air, like in surface BOP step. This one, if you need to apply any function, you need to push first the master valve. Master valve is open air supply system to operate the function you need. What is the optimum pressure for the air pressure in the rig?
100, 120.
Sorry?
100 to 120.
No, actually it is 120 to 125.
Okay. And also, Mr. Hani, there is now, for the remote control panel, there are touch screens now. Yeah.
Touch screen, yeah.
Yeah.
It can be all type like this. This is the master valve, you push by hand down. This is all type. Or this is the electrical one, but still same working with air. You need to apply the master valve. When you push master valve with one hand, that's why it is called two-handed operation. Push and hold, then you push to close any ram or BOP stack. What will happen? First, you will find the light will change from green to red, from open to close, or from red to green to open the BOP. It's changing the light is not indicate the function is done successfully. It is indicate that mean, okay, Mr. Saleh.
Yeah, first the light will go off. Then after some time, the other light will come on.
Yeah.
But as you said, it's not confirmation. The pressure also you need to.
You need to confirm from the pressure.
Yes.
You will see manifold, for example, for RAM drop, then accumulator, then charging back to its normal value. Okay.
Yes.
This indication the function is done. Why? Because a changing color here is related only that mean three position four-way valve is shifted to another position.
Yeah.
Okay.
Okay.
Why it's changing color is why the changing color related to shifting four-way three-position valve, because the sensor for the light is attached to the pack or the side for the four-way three-position valve. So when the four-way it changes position, the color will be changing. After that, you still give order to pressure to go in the closed line to push the ram to close. If
I have a question.
Yeah.
Sorry, I have a question. If there is no air.
If there is no air, no function will be done from this remote panel. You can go
in unit.
In main control unit, you can make it by hand, no problem. But a remote panel, you cannot. But there is, according to the API, if your air pressure drop to 75 PSI, you're still able to do the function from the remote control panel to 75 PSI. Below 75 PSI, you will not be able, like zero pressure.
So you have to go to main unit.
Yeah, you have to go to the main unit. So the minimum for the air pump to apply this function, it is 75 PSI, according to the API 53.
75 PSI, okay.
Yeah, okay. After you push, the pressure will go. If there is blockage, you will not be able to close the BOP. If there is leak, you will not be able to close the BOP or open. But if the pressure coming down and raise up again, that means you make the function correctly. If the pressure drop and not come back again, maybe you have leak or the charging pump is not started to charge the system again below 2,700 PSI. Okay, this is how to indicate any problem in the surface BOP stack control system. In the subsea, it will be a little different. We'll discuss later. Okay.
Okay.
All right. After that, we'll move to talk about a choke manifold. The choke manifold is arrangement for valves to control the fluid or the flow coming from the choke line or from the BOB or from the well. You have mainly in the choke manifold 1 or 2 manual choke. This is used for volumetric method only, and you have 1 or 2 remote operated choke. For 10K minimum requirement according to the API to have 1, but in some rig you have 1 and 1, another one is backup.
Yeah.
So after, what is the function for remote choke is to create back pressure on the well to control the bottom hole pressure during circulating out the influx. The remote choke here, are you going to pressure test the remote choke?
There is no pressure test on the choke. There shouldn't be. Choke is not seal element.
There is a pressure test on the choke. There is.
Remote choke, you will pressure test.
No. For the choke, there is pressure test. For the remote, no.
Let's make it correct. If you have remote choke, it should. It is better. I don't know how can I say. In remote choke, choke should hold the pressure. Choke may hold the pressure, but in general, since choke is not seal element,
okay,
male choke shouldn't be tested for pressure.
Yeah, thank you. Yes, correct. According to the API, will not be or not used to pressure test the remote choke. Just only function test. What mean function test? Open and close and circulate through. Okay, for both primary and backup one. But still in some company, they need to make sure it will hold the pressure while killing operation. So in certain condition, they can close it and they can apply small pressure like 500 PSI, just to make sure it is holding pressure a little bit. But it's not recommended as an API.
Yeah, like usually when we pressure test the choke, we isolate it by the manual valves and just do it for the manual valves.
Okay, this now you pressure test the manual. It's not,
yes.
But I mean you close and you hold the pressure, or the remote choke is not recommended.
Okay.
Okay. And also, as we said, it's not recommended to use the manual choke for driller method and wait. Just use the remote choke because it is easy to handle or control the pressure for the well.
I believe there will be no control on the, when using manual. It will be very, very difficult, because already there is a lag,
Yeah, that's why we use the manual in certain conditions like bleed and lubricate or volumetric method only. Okay. If you have one remote choke and it is washed out or fucked up, you will wait till you fix that one. Okay. This is the manual choke, adjustable choke manual. And this is two hydraulic remote choke. Actually, the hydraulic choke working from the remote choke panel with hydraulic fluid. There is two mechanisms for the operating for the remote choke. One is Cameron type, working with seat and
rod,
stem or rod.
Yeah.
When you close position more, it closes this area, so it means the upstream pressure to increase. This rod or stem is made from tungsten carbide.
Yeah.
Okay. So this is the mechanism for the Cameron one. For Super Swaco one, which is the common type, we use two blades. Okay. It is made from tungsten carbide. One blade, the lower one, is fixed, and the upper one is rotated by pressure. And they cut it in half moon, an open area in half. Okay. That's why how to control the position for the valve. When you rotate Okay, there is percentage for the opening for the choke. When both opening half moon come at each other, that means is 100% open. The other side, it will be completely closed. Okay, this is the mechanism for super SWACO choke mechanism. The remote choke panel located on rig floor, it can be single or tandem. It's contain gauge for drill pipe for casing, stroke per minute, total stroke, lever to control the choke position, here gauge for the position for the choke, and also the air supply. This is control hoses contain hydraulic pressure to operate the down remote choke. If you lost the hydraulic connections hose or the hydraulic pressure is coming down, you can operate with hand pump here. This is backup for emergency. There's a storage tank here for oil. You can operate manually by hand to open and close, or to close the well to control the flow. There is a regulator here also operated by air. This is for the speed for regulation. You can make it fast or slow. We'll see this one today, inshallah, in simulator. This is the panel, remote panel, single one. After that, we'll talk about mud gas separator, or MGS, or bore buoy degasser system. This usually used to separate large volumes and large bubbles for the gas, which is free gas, while killing or drilling operation. The return here is coming from the BOP through choke line. It is controlled by remote choke. Downstream, the remote choke, it will be choke manifold here, down mud gas separator. The mud gas separator contain plates here, so the gas will break going up from the vent line, and the mud will be coming down to dip tube here area, back to shell shaker. This is the surface in land rig, and here the cross section in mud gas separator. If you look here, here is the inlet for the flow coming from the well. The gas will coming up from the vent line. Here the vent line is affected the back pressure in mud gas separator. It should be short to not create back pressure, and it should be enough diameter from inside. After that, the mud is coming down here from U-tube or dip height, coming to shell shaker area. While killing operation, you have gauge here in the top for mud gas separator. This gauge usually ranged from 0 to 50 psi or 20 psi, and is reading the back pressure or the pressure inside the mud gas separator during circulation or killing operation. The mud gas separator is filled normally with the same fluid for the drilling fluid used while drilling. For example, this height, you can measure the hydrostatic head for the dip height here for U-tube, 0.052 by this height, by mud weight inside this area. It gives you certain pressure, for example, 20 psi. You're monitoring this gauge during killing operation. If this gauge reading is still below 20 psi, so everything is coming fine and the gas is coming from the top, and mud come back from below to mud system or shell shaker area. If this gauge now around to reach 20 or exceed, that means the force for the gas will overcome the hydrostatic head for the mud in the dip tube. So the gas will push the mud and enter the shell shaker area, which actually is very dangerous situation because it can burn the rig or the mud system. So how to control this issue? This is called, we have overloading in mud gas separator. It's called you have overloading. So from time to time, you have reduction in the hydrostatic head here. Maybe oil coming or condensate, or you have any hydrates, so it will make reduction. That's why from time to time you need here, there is hot inlet tube connection. You need while killing operation to connect to the active tank, original or kill mud. And from time to time, like every 12 hours for killing operation, you will shut in the well, start to pump fresh mud here inside the mud gas separator to maximize and restore again the hydrostatic head for this area. Yes, Mr. Saleh.
Almost the same of dealing with the trapped pressure in the BOP, right? Same idea, almost.
Same idea. I cannot say same idea because here I pump something and the well is closed.
Yeah.
To restore hydrostatic head.
Yeah.
But when you remove the trapped gas, you not work with hydrostatic head. You just reduce the hydrostatic head and you start to bleed the gas after closing the top ram.
Yeah. I mean, it's almost same concept, not same thing.
Okay, you can see if you want.
Yeah.
After you pump, you restore your hydrostatic head here, so you maximize the maximum operating pressure for mud gas separator. Okay. If you have overloading in mud gas separator, you have option to reduce the pump rate first. That's why we're working with 2 rate for the pump SCR from the beginning. Slow the pump rate, holding current casing pressure or kill line pressure constant. Or if you can open the choke more, or you can bypass the valve to the bleeding line to control the volume coming from the well. This is the main function for mud gas separator. In the IWCF exam, there is one calculation symbol coming to mud gas separator system, talking about you have mud weight and you have oil inside this area. So when you calculate the hydrostatic head, you calculate based on the worst scenario. You have oil, so you deal with the oil in this system, so you reduce the working pressure for the mud gas separator in worst scenario. Okay. Again, the pressure build up or back pressure inside the mud gas separator related to 2 functions, vent line ID and vent line height. Maximum operating or capacity related to U or dip tube height, or sometimes called mud seal level. Okay. After that, we have quick view on the vacuum degasser. Is the vacuum degasser a backup for mud gas separator during killing operation? No.
No.
No. Different.
Why?
Capacity.
Capacity for what?
Capacity, vacuum degasser capacity is much more less than full void degasser.
Okay. And what also?
And also, vacuum degasser is designed to remove the solution gas in the mud.
Yes. Yeah. This is the main concern here. The vacuum degasser is designed to separate small volume bubbles, which is dissolved bubbles or gas from the mud during well control or during drilling, if you have gas cut mud. So it cannot be handled large amount volume bubbles. Okay.
Yeah.
Second limitation, it is mounted above the mud tanks. So it is not be advisable to flare or separate a lot of gas in this area. This is the 2 limitation. So that's why vacuum degasser is not backup for mud gas separator. If you have problem with mud gas separator, you need to stop circulation till fix the mud gas separator. Okay. But you can use vacuum degasser after taking the return to the tank to dissolve, to separate dissolved little bubbles for the gas by vacuum or minus pressure through baffle plate here out to flare line. Then you take clean mud from another tank. Okay.
Okay.
Check this example.
What is the most common? No. D.
It's D.
That's the D.
D, right?
Yeah, D.
It is used to remove gas after the mud has been circulated across the shell shaker area. Okay. Stab in valves. This is the valve we install during tripping operation if you have kick. First one is in the left side is the drill pipe safety valve. It can call TIW valve related to TIW company, or it can call drill tubing safety valve, or full opening safety valve, FOSCV. Usually we keep this valve as well control equipment. So the rated working pressure, like the BOP, it is pressure tested with the same time you pressure test the BOP. Okay, it can be run inside the hole. It's kept the rig floor in open position. You cannot run this one in closed position. It needs to open by wrench or wheel at the or key at the surface. So it is pole type, half pole. It is hold the pressure from both direction, from top and from bottom. This is the full opening safety valve. The first thing you install above the string and close it to control the flow from the pipe. After that, you can going to the right side. This is inside BOP or gray valve or non-return valve. This one also kept a rig floor in open position. You have lock screw here and bar rod. The rod is pushing the spring here for the valve down out its seat. So if you don't have that one, you can install this one direct on the drill string. This one will be installed before stripping operation. So you install that one in the top. After you close that one, then you open this one and you start taking the stand and stripping back to the bottom. This one, it is hold the pressure from below only. If you need to get the value for shut and drill pipe pressure, you need to pump inside the drill string to open the float or the spring type. This one restrict wire line operation, and this one is not restrict wire line operation if you need to run for any reason wire line inside the drill string. Okay, this is the TDS inside BOP, which is hydraulic one. You can control from down. This one is old type. It's called hydral dart valve or hydral dart sub. Do you know this type?
No, I have never seen.
Yes.
You work with?
This is the one with the dart and balls, right?
It is dart and ball or dart and plug. This dart sub, it is running as part of drilling string above bottom hole assembly, above drill cooler. Okay, because the drill cooler have a small ID. After that, if you need to convert to one-way valve like the inside BOP, you will drop from the surface this valve. Okay, bumping behind till it's coming inside its seat here.
Yeah.
Then you can hold the pressure for the well. If you need to retrieve, you can run with a slick line to retrieve again this valve. This is old style or old type.
Okay.
Has some problem because in some cases, when you drop the valve, it is not seated correctly in its place. so it does not hold the pressure for the well. Or when you're pumping behind with high pump rate, the seal element here in the valve itself, it will be eroded or worn, so it will not seal in its place. Okay.
Okay. Okay.
Check these two questions, please.
First one is C.
Okay. Pause is C, right?
Yeah.
You need first step in safety valve, then close it. Also for slip and cut, before you're going to slip and cut, you need to install full opening safety valve only in the drill string in open position for safety, right?
Right.
Okay. Float valves installed as safety on the pit sub above the pit.
Before
is-
slip and cut, you said before slip and cut, you have to install
Full opening
full
safety valve
safety valve
in open position. Yeah. And you can line up to trip tank and set alarm. That's it. If you have flow, you will close the full opening safety valve.
Okay.
Okay. Float valve, this is two type, can be spring or flapper type installed in the bit sub. This only recommendation for most of the client to prevent the kick to enter the drill string or the flow to protect people at the rig floor. The main limitation for float valve is not well controlled or tested barrier, because you don't test at the surface and you cannot have any control downhole during the operation. It can be plugged with any depressors, so it kept in open position or closed position. So this is the main limitation for float valve, is not well controlled barrier. It's just recommendation from the client to avoid backflow during tripping or connection. Okay. Second limitation for the float valve, you need to
What
bump
do you mean
off.
by limitation? What do you mean by limitation?
Limitation, that means disadvantage. The main disadvantage for that one is it is not tested well controlled barrier. You cannot rely on that one as a barrier.
Yes, yes, of course.
Second limitation or disadvantage, you need to bump down the string to open the float to reach shut-in drill pipe pressure at kick situation.
Yeah.
Do you see this one before? Fast shut-off coupling.
No.
This one we used in some old wells, especially gas well. If your string during workover is eroded, so you cannot install or connect to the connection full opening safety valve. In this case, you have fast shut-off coupling. This one is installed above the coupling for the tubing. Then it is latched and sealed around the pipe to stop any flow. This is bar, it will be down the string, and from top here, there is connection. You can install full opening safety valve. This is to control the flow from the old pipe or corroded threaded pipe. This is just surface shut off. That's why it's called coupling, because it's installed in the coupling, especially in the EUE connection. After
Just
that,
it is just for crossover, or
it is it's not. It seems like crossover,
right?
but it is latched and sealed around the coupling for the pipe. It's not connection one. It's not connection type. Just if you need to connect here, full opening safety valve, you can pull head to control the well, for example. you cannot run back
Is the
to the
threads,
bottom.
threads are different because tubings are generally UE, but our full opening safety valve threads are according to the string threads. So this is some kind of crossover in between EUE and full opening safety valve thread.
No, no,
right?
not crossover.
Some kind of crossover.
No, it's not like crossover, because you can bring normal crossover below the full opening safety valve to the thread type. But in this case, the thread for the tubing coming out from old well, especially gas, is corroded. You cannot connect any connection to. In this case, you use this fast shut-off coupling to latch on the coupling for the string, for the box connection. And on the top, you install full opening safety valve to secure the well.
Is this being used now, Mr. Hani? I think I've never seen this.
What mean down?
I mean, is this being used now? I didn't see it in my life.
You cannot run with that one in the hole. Okay, just only for bullheading. You connect, latch quickly, install full opening safety valve, and you pump fluid inside the well port.
Yeah, I mean, it's in use now. Now some people use it.
In one course before, there is some candidate said they use it one time, but it is rarely used actually.
Okay. This is a solution for if the connection is damaged, the one on the rig floor, right?
Yeah.
Okay.
Connection is not damaged. The connection damaged or worn threaded, so you cannot connect any crossover or connection.
Okay. Clear.
Last point here, or last subject in the equipment part, is talking about what is the API wellhead or BOP connection. This is the flange. This is ring gasket. It's written PX type, and this is 3 common connection for the wellhead or the BOP. This is for BOP. It can be clamp hub, or normal one flanged, or studded flange. You have, according to the API, 2 types for the flange. One is called 6P. The another type is 6PX flange. With 6P, we use 2 types for the ring gasket, R and RX. In which rated working pressure we use this type for flange for wellhead or BOP, for low pressure from 2 up to 5K. This type we use PX ring gasket with this type for the flange. This type is from above 5K to 20K. So this one is best for well control or the BOP. This 6PX flange, after you make torque for bolt and nuts, there is gap here between the faces for 2 flange. This is called standoff. But in 6PX type flange, there is no standoff because the ring gasket inside its groove. Okay, so which one is the best for well control?
The right one, BX.
PX is the best one, because if you have vibration or loose, it will not leak compared to 6P flange. Any ring gasket end with X type is called pressure energized ring gasket, like RX or BX. Why? Because there is port, okay, for this ring gasket. When you make pressure test by hand pump, this port will take pressure, make more sealing around or inside its place. Ring gasket is metal to metal seal without any packing element. This PX, this is S, referred to steel or material for ring gasket, like low carbon steel or soft iron, whatever the type for the, and this one 155 is related to size for the ring gasket. The ring gasket is one use. You cannot reuse again. Even you connect and disconnect the flange one time. Why? Because there is little deformation after tighten the flange happen to the ring gasket. Because the ring gasket material softer than the groove material itself to take the deformation. That's why it is only one time use, even it is visually in good condition.
Because that changes the tolerance of the gasket, right?
Yes, yes. How to clean the groove for the ring gasket? According to the API, don't put any grease, just only dry and clean by rag or by piece for clothes. That's it. You don't need to put any grease, because the grease, it will become to contain pressure pocket. So according to the API, it's not recommended to put grease. This is how to install or clean the groove for the ring gasket. For sure, this type is for surface BOP stack or surface wellhead. The connection for the subsea, it will be hydraulic connector with another type for the ring gasket. Okay. Any question?
Perfect.
Oh, thank you. Very clear.
Okay, thank
Very
you.
good.
We
Thank
reached
you.
to the end for the equipment part. Thank us very much.